Okay, so in this tutorial, question 4 then, extracting the information, we're given two scenarios. When x is that, the velocity is 6 meters per second. When x equals 0.2, the velocity is 3 meters per second. And we're also given the natural frequency of this thing. Free oscillation, so it's oscillating at a frequency of 5.319 hertz. So we're after finding initially the amplitude of the motion. So the formula that you might well be interested in is this one. Taking one of the scenarios we've got here, we know that when v equals 6, x equals 0.125. So for a given situation, picking this first one, say, we know that v and we know x. We can find omega because we're given the frequency. So we can then put the values in and work out, again, rearranging this. So this is not an uncommon form to have to rearrange to get r to find the amplitude. So I can write down that, taking the first situation, for example, 0.6 equals omega times the square root of r squared minus 0.125 squared. Is it? 0.125, yeah. Okay. And we can find omega because omega is 2 pi f. 2 pi times 5.319 times the square root of r squared minus 0.125 squared. So we just got a little equation to solve. Divide both sides by 2 pi times 5.319 and then square everything, and away you go, okay, to find r. And you should get the answer in the script if you do that. So to actually calculate it, then the calculation is here. Omega equals 2 pi to f, which is this bit, which turns out to be this. You could square everything, or you could divide both sides by 33.42 at this point. But if we square everything, we get this, and then calculating r. There are the steps. If you want to look at them slowly, you should get an answer around about that. But we're rounding all the way through. We've rounded here, and we've rounded here, and so you might get a slightly different answer. 0.18 has been suggested if you hold on to the accuracy. So that shows the importance of accuracy, holding on to the accuracy. Okay? So to find V max, we use V max equals omega r. Well, we've just found r, and we've just calculated omega. Omega is 2 pi times the frequency, which is 5.319. And so we just times that by 0.22, and there is our V max. So putting the values in, we get around about 7.35 or 7.4. Last thing we've got to find is the periodic time. How do we find the periodic time? Formula? Yeah. And we've got the frequency, 5.319, so it's just 1 over that. Gives us about 0.19 seconds.